Flutube. Get it straight.
Okay, let's take a look again at the conservation of mass problem that we did as a Reynolds transport problem as one of our first problems in Chapter 4 when we were first learning about the Reynolds transport theorem. We have a simple pipe junction. We have a known leak in the junction at 0.4 of 0.1 meters cubed per second. We have a known input coming in at 5 meters per second and across an area of 0.2 meters squared. We have a known outlet of 12 meters per second across an area of 0.5 meters squared. This is 3 here. And then we have an unknown velocity at 2 going across an area of 0.2 square meters. But this is what we're looking for, the velocity at 2. So in this case, we can assume the velocity is either way, but let's assume that it's flowing out. So here's the Reynolds transport theorem. So the total derivative of the mass in the system with time, which is under steady conditions, this is 0. Mass is conserved. So that means that the change of time in time of the mass in the control volume will equal to the negative of the mass crossing over the control surface, the opposite. So that would be from bringing this over to the 0 side. So we end up with this equation here. If we notice that rho is constant, we can take that out of the derivative or out of the integral here and here, pull that out and cross it off because it cancels. We can also notice that this pipe is non-deformable and fixed, so the volume will stay the same size and shape the whole time. That means that the control volume side is 0 as well. So basically, we have the sum of the ins and the outs equaling 0. So conservation of mass in this case. So I should note here that I neglected to write the normal vector here. So this should be v dot n. That tells us if in and out are positive and negative. So we know that in is negative, out is positive here, and out is positive here. And remember that this one was assumed. We didn't really know that one, but we just assumed it. Keep that in mind. So if we solve it and do the algebra, plug in the numbers from the top, we will see that we do in fact get a negative 4.5 meters per second, which tells us that we assume the wrong direction for V2. So that's no big deal. We just have to go back up and say, oh, it's not flowing out, it's flowing in. So this leak is kind of causing this flow to go the opposite way, or it was intended to go that way and we just didn't know it. Either way, we figured it out, and that's it.